uploading resume on naukri.com, on which websites?
Naukri, LinkedIn, Apna, Monster Bear,
Moserware.
Monster Bear, something on one website will be there, right?
Okay.
In all sessions we will upload. Documents also I'll take care. Okay.
Okay, sure.
See, in this we will go to next section is IPC. Okay. That means IPC means
Okay.
interprocessor communication. In that, what will happen means one one class to another class. If you want to transfer the data, then it has to go through with some rules and regulations, right? Directly, it can't transfer right from one block to another block. So
Okay.
again,
Some protocols are there.
yeah. You shouldn't call protocols. Protocols are different. Those are rules and regulations to do something a very big task. These are some small simple things. See, from one class to
Okay,
another
rules and
class, directly they can't communicate without
okay.
rules and regulations. Protocol is also rules and regulations, but that is a high end task. That protocols we will discuss. Among them, first one is semaphore. What is semaphore means? Semaphore is a block. Okay, it will connect from
Okay.
one to another. It will have some keys. Number of keys will be there.
Okay.
Okay, that keys
Okay.
until and unless those keys are put and get. So we will put the keys and we will get the keys in another class. We will put the keys in one class.
Okay, we are saying that we need to access the keys to be able to approach the block.
Yes. We'll go through that now.
And if keys, there are n number of keys, and if the keys get like keys are no more there, all the keys have been used.
Yes. If we are getting those keys means, if you are get those keys means after that communication has been completed and uh, it will go to that blocking will be completed. It will go to next thing. And
Okay.
there is called one thing is called mailbox. Mailbox means
Okay.
we will put the data uh, we will do randomization, right? That randomized data
Okay.
or constant randomization or pre-randomization or post-randomization, whatever may be randomization. You did some randomization that got some data that you will put in mailbox. Okay, you will send from
Okay.
generator to the driver class. There are classes names I'll teach you. Okay. Prior to that, I'm telling, but
Okay.
don't mind. From generator to driver as well as generator to monitor, we will send pockets.
Okay.
Say as of now, we will see this first. Semaphore. Semaphore is a system will have built-in class used for access control of shared resources and for basic synchronization. There will be a synchronization. Okay. Because of this, a semaphore is like a bucket. You know bucket, right? In
Right.
a coding language, bucket. With the number of keys,
Okay.
a process using the semaphore must be procure a key from the bucket before they can continue to execute. If it want to execute, means it has to procure the key, and all other processes must wait until sufficient number of keys are returned to the bucket. Sufficient number of keys are returned to the bucket. Until then, it has to wait. Okay, imagine situation
Okay.
where two processors are trying to access a shared memory area. Two processors are trying to access a shared memory area like a shallow copy. Okay, shared memory area, right? That is. So at that time, if one is
Okay.
accessing, other also tries to access, means there will be a corrupt of data. At that time, what will happen means we should wait until and unless completion of first process, and iteration should start second process. At that time, what we will do is we will put keys in semaphore and we will ask you to wait. After that it has to after completion of this, second process will join and it will do it work. Okay, where one processor try to
Okay.
write and the other processor trying to read the same memory location. Then there will be corrupt, right? At the same time,
Okay.
if it is trying to read as well as other second processor trying to read and first processor trying to write, so it will get corrupt, right? Data, it will get instability, that is called metastable. So this leads to unexpected result. A semaphore can be used to overcome this situation. Semaphore syntax: semaphore name, semaphore methods. Semaphore is a built-in class that provides the following methods. New creates a semaphore with a number of keys. Get obtain one or more keys from the bucket. Put return one or more keys into the bucket. Try to obtain the one or more keys without blocking. New put, don't read the theory. You'll go through simply what I say. That's it. Semaphore example.
Okay.
This is semaphore example. Okay, in this semaphore sema is the sema is a declaring semaphores. Sema initial begin semaphore new of one means how many keys will be there?
How many keys? One.
Yeah.
One key. Yep.
Display
We have
process
created
one.
one key.
Display, see here, fork join. You know fork join, right?
Mm-hmm. Mm-hmm.
What will happen in fork join?
All processes will get completed
No. How it will complete? In begin and also it will complete.
simultaneous. Simultaneously, all processes will process one, process two, both will complete
Yeah, parallelly.
parallelly.
Okay.
Okay.
Task automatic display. Okay.
Okay.
Sema getting one key from the sema. If there are more keys, then sema 3, sema 4 like that. Display dollar time,
Okay.
current simulation time. After that, has
30
30 means
nanoseconds.
what?
30 nanoseconds.
Very good. Sema put, again putting one key to sema. End task, end module.
Hmm.
Let us see run. See, current simulation time 0, 30 nanosecond simulation time. Okay.
Yes.
Because we kept
Okay.
it will execute in 0 nanosecond only. It will take 0 time to execute it. But you kept delay here 30 nanosecond. That's why it is taking 30 nanosecond. Okay.
Yes. Okay.
In example below, creating semaphore with 4 keys. See here, sema equal to 4, right?
Yes.
So it is creating with 4 keys. And getting also, sema get 4 keys, getting 4 keys from sema. Not only one time, we can
Mm-hmm.
get one by one like that also. One key, 2 keys, one key, 3 keys, like that also we can get. Okay.
Okay.
It will give so much synchronization. So how much time it will execute right now? You see and tell me answer. How much time it will take?
Stem of four keys. Get four. Getting four keys. 120 nanoseconds.
Why 4 keys? 4 keys also it is taking same time, right? It is not taking one key 30 nanosecond, one key 30 nanosecond. It is taking
Okay. Simultaneous. Okay. I understood.
0 30. Okay.
Okay.
But here keys are increasing. We can take more keys also.
Okay.
Semaphore with two keys, access method. At the same time, two processes will get the access to the method and other process will be blocked until the one process uh, one process will put the key. Okay. See here, how many processes
Okay.
are there? Three processes, right?
Three.
So,
Yes.
so here put creating with four keys and getting two keys. Okay, from SEMA.
Hmm.
Display time. This will display
Mm-hmm.
time. After display, again two keys are putting. Okay.
Mm-hmm. Okay.
See 0, 0, 30 nanoseconds. Okay.
Okay.
Current simulation time.
Okay.
Put back more keys. Model semaphore. This is somewhat tricky. You see. See module semaphore X. Semaphore sema. Initial begin. Semaphore one. Creating with one key. Four join. How many? Three processes. Join end. Again task. Okay. Task automatic display int keys.
Mm-hmm.
Sema dot get key. Display dollar time current key.
Mm-hmm.
Here key is a variable. Okay. Again
Mm-hmm.
sema equal to put key plus one. Putting key number of keys to sema again. End task, end module. So we'll see how it will run. See at zero current simulation got one key. 30 simulation time got to second key. 60 simulation got third key. Because it is running at one time 30 nanosecond. Again put key plus one next key. Again 30 plus 30 60 nanosecond. The process with more than one key. Here see, here display one key, second key, third key. This is key only. Understand? This is at 0 nanosecond. This is at 30 nanosecond. This is at 60 nanosecond. 30 plus 30. Okay. Here also model semaphore X, semaphore sema, four keys, two keys, three keys, two keys, one key. Let us see how much time it will take.
Okay.
0 simulation time 30 30. Okay. This we'll see. For this, you tell me. Initially, we are creating four keys. Four keys, four keys. Task automatic display, sema dot try get key, uh, dollar display, dollar time. Okay, 30. Again, putting the key. How much time it will take?
30.
Let us see. Zero nanoseconds only. It is not even coming into this 30-second block. Four keys, they are putting four keys, they are taking at a time only. I thought you will tell that answer. See here, putting four keys, right? Creating. Process one, process two, taking in the 4 gen only taking four keys. It is not even coming into this block.
Hmm.
This is happening
Hmm.
in 0 nanosecond. Mailbox. What I told about mailbox? Mailbox is like a memory and as well as encapsulation something. One block, okay, that will store as much as possible. See, for example, sometimes transaction could be each transaction, for example, 1 megabyte also. That also it can hold. And it will take this to the next class. Mailbox is a communication mechanism that allows messages to be exchanged between processes. Not only processes, between classes also. From one class to another class. I explained you about test bench architecture, right?
Right.
You remember? Do you remember test bench architecture?
Yes, 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 yes. You
Can
explained.
you tell me once?
Interface, DUT.
Ah, very good. Tell me
There
once.
was an interface. There was interface. There was DUT,
Hmm.
and there was driver. There was monitor. There was generator,
Hmm.
and the driver cannot access DUT directly. It has to go through the interface. So for a driver, for a interface, driver is the input, but it is giving output to DUT. Like that, for a interface, for a DUT, the input is coming from the interface. So input and output for each components become different. And there is one environment, and test bench with the environment, with this interface and DUT, the environment is known as test bench with all the other components.
Tell me one thing I want to clarify. You are telling by seeing the notes or directly telling?
For first two or three sentence, I without seeing the notes, then I looked at the notes.
Okay, okay. I thought that much you remembered without without any wrong. That was
Then
very
I remembered, I remembered, I remembered that test bench has a driver interface, DUT
okay,
generator.
okay.
This I knew,
That
but
is clear.
the architecture I looked at from the notes.
Okay, okay, whatever. But still it is great actually. Okay, you explained very neatly. But between generator to the driver, okay, those two are process, those two are
Okay.
classes, right? Okay, for
Yes.
those, we need to send data from generator to the driver and generator to the monitor. Okay, for these blocks, what we will do is
Yes.
we will put the data, whatever the transaction is, transaction randomized data is there, that in the uh, generator, and we will send it to the, and we will send that to the what driver.
Driver.
Yeah, processes. The process for which we want to talk, the processes post the message to the mailbox, which stores the messages temporarily in a system defined memory object to pass it to the desired process. Which process, if you want that, based on the sizes, mailboxes are categorized as bounded or unbounded. Okay. Bounded mailbox means limited memory.
Okay.
Unbounded means it doesn't have a limit to the memory. Okay. Mailbox types, generic mailbox, parameterized mailbox. Most of the times we will use only parameterized mailbox. Okay. Generic mailbox is default type that is used for mailbox can be sent to receive the data for any type. Mailbox name. Parameterized mailbox with a particular type. Mailbox with parameterized mailbox is used to transfer the data for particular type. Mailbox uh, has type mailbox name. Mailbox method. System verilog mailbox is a built-in class that provides the following methods. These can be applicable for both generic and parameterized mailboxes. New, put, try put, get, or peak, num, try get, or. But in this we will get to put and get. Only these two. Okay. Only these two remember. Most of the
Okay.
99.99% we will use this only. Don't remember, don't study also these things. Unnecessary things. Okay. Process 1 generator class. Here, see example is given. Process 1 is generator class. Okay. Will generate the created randomizer packet and put it into the mailbox. You are thinking one packet or two packets, but I am telling like 100 MB also it can take. Unbounded mailbox. That much memory created, that much it will take, that much it will carry from generator to the driver. Okay. Packet into the mailbox MB box. Put process to driver class gets the generated packet from the mailbox and display the fields. Okay. Here, see, this is an example. Packet rand bit 7 down to 0 address, rand bit 7 down to 0 data, displaying random values. Function void post randomization. This is post randomization. Dollar display packet colon packet generated. Dollar display packet colon address percentage 0D. 0 means 0 decimals. Okay. Here 1 means 1 decimal. For example, 7.1, 7.2 like that. 2 decimal means 2. Precision that is called. D means decimal value. Data means 0 percentage D address comma data. And class generator. In generator, what we will do generally? We will take the classes class handle. For that handle, we will take the mailbox. We will create the memory for it, and we will randomize that data, and we will put that data into uh, put that data, and we will get the data and driver. Okay. See, this is dollar display, right? Generator packet. We are creating a handle mailbox M box. Okay. Here we are creating a constructor. Okay. Task run. Repeat 2 times. 2 times randomize means what? Two two random values. Okay. Repeat 2 packet equal to new creating a constructor. Slow. Packet dot randomize generating a packet. Mbox dot put packet. Putting packet into the mailbox. Dollar display. Generator. We are putting C.
Yes.
Class driver. Packet mailbox mbox. Here again constructor we are creating. Always we need to construct the constructor like this mbox box. Repeat 2 times. Mbox dot get packet. See, I told you, right? Among them all the things
Um.
you need not to learn. Only two things. One is put, another is get. Okay. This get the
Hmm.
packet. That those values will be get, and those will be test. These two are in test bench. Okay. We need definitely module for displaying the values. Without this we cannot. Module mailbox generator gen, driver drv, mailbox mbox. This we are declaring the all instances. These are called instances. We are creating all the instances. Okay, wait a second, we will do it. Mbox equal to new creating a mailbox. Okay, gen equal to new, again creating a new mbox. We are transferring into gen. Driver new mbox, creating a driver passing the mailbox handle, creating the generator passing the mailbox handle. Fork join generator dot run process 1, driver dot run process 2. Okay, you have to run to transfer the data. Okay, see what we will get. See, packet generated, address 125, data 212, generator packet put into mailbox, driver packet received. Driver is telling packet received. Driver values 125, 21 data. This is for packet number 1. Again, packet number 2, packet generated, address is 249, data is 129. Data generator is packet put into mailbox, driver received, driver address 249, data 129. Got it?
Hmm.
So till now, how much you completed? System Verilog? 90%. These,
I
these
don't,
are the,
I don't, oh,
these are the same things
okay,
will be happen in UVM also. Little bit change. Okay. So in UVM
okay,
also 40% you completed, 90% in SV, system Verilog. That's it.
okay.
Remaining 10% we will complete. We'll see. System events. Events are static objects useful for synchronizing between processes. Event operates are two-staged processes in which one process will trigger the event, other process will wait for an event or to be triggered. Okay, events are triggered using, this is called this operator is called implication operator. This is this is also one of the operator. Wait for an event, wait operator is at operator or wait colon. Events are triggered using this operator. Okay, system Verilog events act as handles to synchronize queues. Thus, they can be passed arguments to tasks. They can be assigned to one another compared. See, these things looks complex. Little bit, I'll simplify. See, tasks will take time, right? Queues means memory, type of memory. From that one queue to another queue, in data transferring or executing the codes, it is taking some time. Before it is even completing, if we send another data, there will be a collision. There will be like mismatch of the data. To avoid that, we will ask this system to, we will put it in a event queue stating that it has to wait some time. Okay, so it will wait at that time. So after that it will send the data. Event triggering, implication operator. Named named events are triggered via implication operator. Triggering an event unblocks all processes currently waiting on that event. This operator non-blocking events triggered using this operator non-blocking. Waiting for event trigger at operator, or wait bracket open bracket close. If the triggering and waiting for event triggering with the operator happens at the same time, okay, at operator may miss the detect the event trigger, whereas wait constructor detect the event trigger. This much depth is not required for you. Okay, wait order, this much you will get confused. Unnecessary things, these are unnecessary. Merging events, event examples. See, fork giant, this is fork giant. In this, process 1 triggers at 40 nanoseconds. Display time, this is the display time. This is a implication operator. It process starts and ends. And this is begin end. This is event 1, triggered and displayed. So these are the things happens. We will see how it will be, processor will be. See, 0 for waiting event trigger, 40 for triggering the event, 40 for event triggered. Okay. Waiting for a trigger. So this much knowledge is sufficient to enter into the SV classes. So we will deep dive into these things now. Okay.
Okay.
Now our task is to generate a clock and reset. Why? Clock and reset always will be generated from the top test bench. Okay.
Okay.
So how we will generate the clock and reset signals? Okay, we'll see. Simple example. See here, module TB, global signal clock and reset, reg clock, reg reset, reg 3 down to 0 temp. One temporary variable we are taking. Initial begin. See, whatever may be the values, your hardwired values or anything, if you want to do it means in a module, initial block only you need to do it. In initial block only you need to do it. Okay. So this block is called procedural block, initial block and always block. But test bench will be test bench mostly 99% you use the initial block only. Always block is used to generate the clock, or forever block also. With the forever block also you can generate the clock. Okay, clock equal to 1 tick B0, reset equal to 1 tick B0. Initial begin, reset equal to 1 tick B1. After 30 seconds, reset equal to 1 tick B0. See, most of the times reset will be reset will be 1. Most of the times for all synchronized asynchronous circuits, most of the circuits are asynchronous circuits. The circuits which are depending on the
Okay.
clock as well as the reset. Clock as the reset are the external hardware pins, those are. See, clock pin is also there, reset pin is also there. Some pins are logical pins, but these pins are hardware output pins. Okay. For reset, initially,
Okay.
wait, I'll draw so that you can get more. Where is initially? Okay, this is logic high. 5 volts are logic 1. Okay, reset will be logic high. At that time, most of the circuit resetting, we will do resetting the circuit. Okay, we will do resetting the circuit. Here, we will initialize and circuit will function in reset 0 most of the times. Okay, understood or not?
Okay. Yeah, understood.
Here, clock will be generating. Okay, clock initial value is this one. This is initially assigned to 0. From here to here, some duration will be there. This is time, this is on time, this is off time, both together called one clock period. Okay, so we initially we are making it 1. After 30 nanoseconds, it is making it 0. Initial begin. Temporary values we are giving temporary values 0 1 double 0, which means 4. It is 12. It is 3. This is 10 nanoseconds gap is there. Dump files. Okay, this dump file $dump file is used to display display these variables in, okay, graphically.
Okay.
Waveforms, you should show waveforms means dump.vcd, we need to do it. Okay, dump.vars.
Okay.
Initial begin. Monitor, $monitor, which means the display, that is also display only. Okay, temp value 0
Okay.
percentage at time of, at which time. Okay, after that temp
Okay.
dollar time means time. Temp means temporary variable, these temporary variables. After 200 nanosecond dollar finish, this we need to put. Otherwise this will be clock means this will be continuously going, right? So it will get crash, software will get
Mm.
crash if you don't tell like where to stop. You understood, right?
Okay.
Okay,
Right.
first what we will do is we will see this is log file. Okay, or log file or console file, we will call it as console. Okay, after that we will see waveforms. First I'll commenting it. If you see log file, you will get an idea. After that we will see in waveforms. See, at 4 temp at 4 nanosecond 0, at 12 nanosecond this one